Section 4 in Chapter 2 ties together all three of the sections that we've done so far. Solving equations with variables on both sides of the equal sign. That means you're going to be moving variable terms as well as constant terms, just numbers. Remember the goal. You want to get all the x on one side and the number on the other side. So you can move a variable term just like any other term using the properties of equality. We haven't done that yet. We're going to do it today. If I want to solve this equation, 5x plus 2 equals 2x plus 14, I have to get all the x terms on one side and all the constant terms on the other. For now, let's just get the x terms on the left side and then the constant terms on the right side. It doesn't matter which side you put the x terms on. I'll talk a little bit later about when sometimes you might want to put the x term on the right side. For now, though, let's just do the left. So if I want to get all of my x terms on the left side, notice that I already have that one sitting there. I have this one on the wrong side. So how could I get this one to go away on this side and pop up over here on this side? This is a whole term that I want to disappear, right? I want to move it over here. So I got to get it to disappear over here. How do I undo a positive 2x? A minus 2x. Turn it into 0. So I subtract 2x from both sides. And notice how I wrote that. I wrote minus 2x underneath the positive 2x. And then over here, I wrote it directly underneath that 5x. I'm like lining things up, okay? So on the left-hand side, I have 5x minus 2x, which turns into what? Yeah, 3x. Like 5 apples minus 2 apples is 3 apples. So 5x minus 2x is 3x. I didn't do anything to that plus 2, so it stays plus 2. The equal sign comes down. 2x minus 2x is 0. It's gone, which was the whole point. And then we're left with that positive 14, so I'm just going to write 14. That's positive. Now that I've done that, we're right back into section 2 again. We have a two-step equation that we need to solve. So what do I do now? Subtract 2 from both sides. What's really happening here is I wound up with my variables all on the left. So now my numbers are all going to need to be on the right. So I need to move that term over here. So I subtract 2 from both sides, which gives me 3x on the left. 2 minus 2 is 0. It's gone. Equal sign comes down. And then I have 14 minus 2, which is 12. And now we're back in section 1. How do I solve this equation? Divide by 3. Divide by 3. X equals 4. Check your answer and make sure that it works. We have 5 times 4, which is 20. 20 plus 2 is 22 on the left. We have 2 times 4 is 8. 8 plus 14 is 22 on the right. 22 equals 22. So x equals 4 is the correct answer. I want to point something out. This equation right here, this equation right here, this equation right here, and this is an equation right there. All 4 of those are what we call equivalent equations. They're all exactly the same. I can take this equation and solve for x, and I get x equals 4. I can take this equation and solve for x, and I get x equals 4. This equation, solve for x equals 4. This equation already says x equals 4. All 4 of these are exactly the same. They look different, but they are in fact exactly the same. They are equivalent equations. All right, I'd like you to try the second one. Go ahead. All the variables go on one side, all the numbers go on the other side, and then you solve. Yeah, we want to get the k term all on one side, and right now they're on opposite sides, so we're going to subtract 4k from both sides. When I do that, what do I get? 3k plus 2 equals negative 10. Don't lose your minus sign there. That's a minus 10, negative 10 sitting here. Now what? We want to get the k term by itself, so we subtract 2 from both sides. And now we have 3k equals negative 12. One more step. Divide both sides by 3 to get k by itself. K equals negative 4. How many of you checked this? No one. Oh, one person did. Check your answers. Negative 4 times 7 is negative 28. Negative 28 plus 2 is negative 26. Negative 4 times 4 is negative 16. Negative 16 minus 10 is negative 26. The people who check their answers are the people who are going to be very successful, not just in this class, but in every single math class that you take from now until the day you graduate. Trust me. Make that a habit. All right, now we have a story problem. It takes a graphic designer 1.5, what is that H meaning? Yeah, 1.5 hours to make a one page of a website. Using new software, the designer could complete each page in, what does that say? 1.25 hours? That's 1.25. 1.25 hours. 1.25 hours. But it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? So this is a pretty typical story problem that you can get from what you know how to do now with equations. What they're doing here is they're lining out all the stuff that you know. This is what they gave you in the problem. Then they're telling you what you need. The number of pages the designer needs to make the new software to make for the new software to save time. If you look at this last sentence right here, how many web pages would the designer have to make in order to save time using the new software? That's what you need. That's what you're looking for. So what are we going to do? Well, we need to write an equation and then solve that equation to find out the answer. So what they're saying here, this comes straight out of your book, by the way. They do this all the time in your book, is they're saying, okay, what I'm doing is I'm thinking about how to set up this equation. And if I think about it, I can say the current time it takes to design a web page is equal to the design time with the new software plus this thing, the time to learn the new software. If I just keep doing the same thing without learning the new software, and then person B over here, like Miss Jackie or something, learns the new software, and she starts making web pages with that new software, when will she and I have made the same amount of web pages? Because this is going to take less time over here, right? I take longer once she's learned that software. So eventually, she will catch up to me and pass me. Okay? It's like if you were in a race. You run faster than somebody, so you let them have a head start. What happens eventually? You catch up to them, right? And you pass them. So that's what we're looking for. We're looking for how many web pages would the designer have to make in order to save time using the new software. We're finding where these two catch up, where the one catches up to the other and where they're exactly the same. After that, the new software will be better than the old software. So that's what they're trying to say here. So what we're going to do is we're going to let P, notice the first thing they do after they think about all that is what do I call that? With that let P equal, what are they doing there? What? No, they're defining a variable. Okay, that's the first thing you always do with a story problem, defining a variable. So you have P equals the number of pages the designer needs to make. It's already written there. I would write P equals number of pages. Any story problem needs to be started off with define the variable. Now we want to say how long will it take using the current design time to make P pages. How long does it take to make per page? Yeah, up here it says 1.5 hours to make one page. That's like the per page or each page or for every page. That's the clue that tells you there's your variable. So I have 1.5 P. 1.5 hours per page. 1.5 times P. Equals. Now 1.25, because that second like the new software takes less time, the 1.25 hours, 1.25 P, 1.25 H up here stands for hours. A little confusing. But we also have that time that it's going to take you to learn the new software, right? So plus 8 hours to learn that new software. That's the equation. What this will give me is where P, the number of pages, how many pages will it take for both of us, for her to catch up? After that, she's beating me. Okay, so what do we do? Notice that on this side we have P by itself. We have a number over here. There's a P sitting here also. So if I move this over here, will I have all the P's on one side and all the numbers on the other? Yeah, that's the goal. So I want to actually move this guy. Subtract 1.25 P from both sides. By the way, what is 0.25 as a fraction? 1/4. What is 0.5 as a fraction? 1/2. Okay. So if I have 1.5 P minus 1.25 P, what do I get? 0.25 P. So I have 0.25 P, which is actually what? 1/4 P. 0.25 is 1/4. Remember all those decimals that I had you guys learn? This is where it comes in handy. Equals what? Just 8. So now how could I get 0.25 P to be just P? Yeah, you could divide by 0.25. Would that be fun if you don't have a calculator? Right. Think about this. The 1/4 P. How could I get P by itself if I'm using 1/4 instead? Multiply by 4. So rather than divide both sides by 0.25, which is legitimate, it would give you the answer, I can make life easier on myself if I don't have a calculator by multiplying both sides times 4. And now I get P equals 32. I didn't even need a calculator for that. 32 what? Pages. So let's put this answer into like a sentence. Under this situation here, if I am the original thing and Miss Jackie is we're using the new software, Miss Jackie will catch up to me when? At 32 pages. We will both have created 32 pages. After that, she will have made more pages than me, right? So who will be better at that point? Miss Jackie will. That's all algebra is. You ask a question, set up a problem, solve it, and then you know. Okay? So a lot of us are struggling with this problem. Let's take a look at what it says. Office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. In how many months will the copier pay for itself? This is actually a pretty realistic problem. People do this sort of thing all the time. Maybe your family has thought about buying a car that has good, what? Gas mileage. Because if you have a car that has good gas mileage, you're going to spend less money on gas, right? So I've actually done some thinking on that situation. For me, in my situation, I was thinking about buying a new car instead of having my truck, which only gets about 12 miles to the gallon. It's terrible. I figured out that it would take me, if I were to buy a new car, brand new car, with good gas mileage, I'm talking like 40 miles to the gallon, it would take me about 12 years to see any benefit in getting a car with good gas mileage. So even though I'm not being environmentally friendly, I'm being economically smart by not buying a car with good gas mileage. Because of how long it would take, 12 years for me to spend the same amount of money on gas in my truck, just driving my truck, as it would for me to spend money on a new car and then the money on top of that for the gas. Now, if my truck dies, then I have no choice, right? Of course I'm going to buy something with good gas mileage. But that's a dilemma that faces a lot of people in the country right now. Do I buy a car that has good gas mileage or not? A lot of people will just go buy that car that has good gas mileage and not realize that they're actually spending more money, even though they're saving money every time they go to the gas pump, right? It's interesting how people will think about that sort of thing. So anyway, this is the same type of problem here, a little bit simpler numbers though. Office manager spends $650 on a new energy-saving copier. What is the current electric bill per month in that office? $112. The new copier will reduce the electric bill to $88. And we want to know, when will the copier pay for itself? That's a very realistic thing. So the first thing we need to do in this problem is what? Define your variable. What is it that we're looking for? Months. So what should my variable be? M equals number of months. In how many months will the copier pay for itself? That's where you get that variable from. Now that I know that I'm looking for months, I write an equation. I have the old copier on one side and the new copier on the other side, and then I can solve for M. So let's do the old copier first. What can I write if I write my equal sign here? We'll put what it costs for the old copier on the left. No, that's how much you spent on the new copier. The old copier is already paid for, right? Like my truck, it's already paid for. It's $112. M. $112 per month. Now on the right side, we'll put all of the money that we're spending on this new copier. We have to spend that $650 just to get the copier. Then we plug it in, and we start paying for electricity on it, right? So plus, what? $88 per month, 88M. Now we have an equation written, we can solve it. What should we do? Yep, subtract the 88M from both sides. We want to get the variable terms all on one side, and that's what we're doing right now. Then the constant term, the number term, will be on the other side. So what is 112 minus 88? 24? Okay. So that's a positive 24M equals $650. Divide both sides by 24. And I get M equals so what is it? What is it? 27.08 units. Is this houses? What? Dollars? Dollars. M stands for months. So 27.08 months. It says, in how many months will the copier pay for itself? 27.08 months. You only get a monthly bill, so the copier will not have paid for itself after 27 months, so my answer needs to be 28 months. 28 months, little over 2 years, and that new copier that you spent $650 on will have saved you so much money that the copier will actually have paid for itself. And after that, that copier is basically free. It's paying for itself as it goes, and now you're saving money after that. Does that make sense? So it's like the car example. I'm not saving money until I've spent so much in gas that the gas has paid for the extra cost for me having that car. And based on my calculations, it would take me 12 years. In 12 years, that car is going to be dead. So it doesn't do me any good at this point to go buy that new car, because I'm going to have to buy a new car anyway after that 12 years. There's no point. Okay, 11 through 19 odd, you guys are capable of doing that now. I'll give you, that's only like 5 problems, so I'll give you like 7 or 8 minutes. Go ahead. So on these problems, what's different? Looking at the distributive property again, that's right. And now after we distribute, what is the first thing we do immediately? Combine like terms. You always want to start the problem off, like we talked about last time, with combining like terms. Do that and then start solving the problem down. So I can see here that I just have a distributive property situation. Here I just have distributive property situation. So I'm going to take out the distributive property thing that's happening right now. What do I get on the left when I distribute? 10x minus 2 equals 3x plus 33. I can take out both sides at once. That's fine. And now we're just right back to where we were like 5 minutes ago. What do I need to do? Yeah, we want to get all the variable terms over here. It seems like a good idea to subtract 3x from both sides, so that's what I'll do. What's my new line? 7x minus 2 equals 33. Good. Now what? We got to get rid of the minus 2 on that 7x. All the variable terms on the left, all the numbers on the right. This guy's in the wrong spot, so we got to move him by adding 2. Add 2. And now we have 7x equals 35. And divide by 7. And we get x equals 5. We should probably check this one. Take the 5, plug it in. It's very easy to check these. 5 times 5 is 25. 25 minus 1 is 24. 24 times 2 is 48. 5 plus 11 is 16 times 3 is... This is the one that I said you need to know because it pops up all the time in this class. 3 times 16, 16 times 3, 48. This is the correct answer. All right, talk me through this. I'm just going to go around the room and call on people and have you tell me what the next step is and what the next line is. So can we start off with Riley, please? Okay, so what do I get? Plus 4. Minus 26. All right, go ahead and call on somebody. Next line, or next step. Good. What is our goal here? To get the variable term on... The goal is to get the variable term, or variable terms, on just one side. Right? So you are doing that by subtracting 2y. Good. And what do we get? 6y. Is that it? Plus 4. Equals negative 26. All right, go ahead and call on somebody. Jose. What's next? Good, because now we got to get the variable term by itself completely. So minus 4 on both sides. And what do we get? Good. And call on somebody. Divide both sides by 6, and we get I got to write y equals negative 5. Good. The whole answer is y equals negative 5. You started with an equation, you're going to finish with an equation. This is an equation. Looks like an answer, but it's an equation. Okay? Go ahead and call on somebody. Let's do the next one. Who? Oh, okay. Yep, so what do we get? 49 minus 7a, 3a, minus 12. Nice job. Now what do we do? I didn't do it on the last two problems. What are we supposed to do next? Yeah, always look for like terms to combine. Look on the left side. Do we have any like terms here? No, unless I have really bad handwriting and my 9 looks like an 8, but no, this is a 49 here. Do I have any like terms here? No. So now what do? Subtract 3a from both sides. Minus 3a, and what do we get? Go ahead and call on somebody. That's a 49 with my awesome handwriting. That's a negative 7a minus 3a, which turns into, it is negative, but both signs are the same, so it is negative 10a, good. Equals, what's on the right-hand side? Negative 12. Okay, go ahead and call on somebody for the next step. We're running out of boys here. Good. You want to get the variable term, which is this guy right here by itself. So that means this has to disappear. That's a positive 49. So to get it to move, we got to subtract 49 from both sides. And what do I get? On the left I get, it's negative 10a equals negative 61. Okay, go ahead and call on somebody. Somebody who hasn't been called on yet. Somebody who hasn't been called on yet. Girl's turn, I guess. Divide both sides by negative 10. Good. And what do we get? We get an equation. A equals, that's a negative 61 divided by a negative 10, which is positive. Negative divided by negative is positive. 61/10 is a fraction. Does it reduce? Nope. 61/10 is your answer. All right, call on somebody. What do we do next on the last problem? Okay, so what do we get?
6x plus 2 equals 4x plus 20.
4 times negative 5 is negative 20, so minus 20. Okay, good. Call on somebody else? Good, we're trying to get the variable terms all on the left side. So subtract 4x from both sides. And what do we get? 2x plus 2 equals negative 20. Nice. Okay, call on somebody else. All right, now we want to get the variable term completely alone, so we subtract 2 from both sides. And what do we get? Equals negative 22. Nice. And one more person. Divide by 2. And the other side, okay. And we get negative 11. There's your answer. So that's the idea. You got a distributive property situation going on? Fine, take care of it. After you distribute, what do you look for? Look for like terms to combine. There weren't any on any of these problems, but there will be eventually. Always look for like terms after every step you do. Next. We have more problems to do. So where did we leave off? All right. Look for like terms on that first problem. Do we have any? On the left side? No. On the right side? What is going on first on this problem? All right. So in the distributive property on the right side, I will take care of that. I'm not going to do anything to the left side though, so I just rewrite that. So I write 10x plus 12 equals, and then I distribute. 2 times 5x is 10x, 2 times 6 is, so I write plus 12. You might have some little sirens going off in the back of your mind, but not really understand why at this point. What should we do now? Okay, subtract 10x from both sides to get the variable term all on the left side. What happens on the left? What do we get? 0x, or just 0, it's gone. Plus 12, so I just write 12, equals. This is also gone, 12. Hopefully that siren got a little louder in your head because 12 equals 12. Is that true? 12 doesn't equal 12? 12 does equal 12. Does 12 ever not equal 12? But it's not. It's 12. Right? Does 12 ever not equal 12? No. So this is always true. We wound up with an always true statement. What that means is I can take any value for x I want. I can take any number I want and plug it in right here, and I will get a true statement. It might not be 12 equals 12. It might be 4 equals 4 or something like that. But it will always be a true statement. And if it's always a true statement, then that means that the answer is all real numbers. This is what we call an identity. If you look in a mirror, what do you see? You see yourself. You don't see me, right? Hopefully. That'd be weird. If I'm a vampire, you'll see me when you look in a mirror? Oh, yes. But if you look in a mirror, because none of us are vampires, you won't see me, you see you, right? That's an identity. That's who you are. If 10x plus 12 looks in a mirror, what does 10x plus 12 see? It sees 10x plus 12. When you have a situation like this where the same thing equals the other thing on the other side, then you have what's called an identity. All right? And the answer is all real numbers. Let's take a look at the second problem. 9m minus 4 equals negative 3m plus 5 plus 12m. What should we do first? Yes, combine like terms. On the left side, do we have any like terms to combine? No. On the right side, do we have any like terms to combine? Yes. So on the left, I will rewrite 9m minus 4 equals, I got negative 3m plus 12m becomes 9m. 9m plus 5. And again, there should be a little warning siren going off in your head, maybe not quite as loudly as the other one was. But what should we do next? Okay, we subtract 9m from both sides. And what do we get? Negative 4 equals 5. Is that true? No. Our variable is completely gone, and we have negative 4 equals 5, which is false. So what we're going to do is we're going to put the little slash through the equal sign, which means not equal to. Negative 4 is not equal to 5, which means that we have no solution. That's this case right here. We have identities now, and we have equations with no solution. So it's possible to wind up with a true statement always and have the answer be all real numbers. It's possible to wind up with a false statement always and wind up with no solution. Okay? So take a look at the third problem. What should we do first? Distribute the negative sign. Okay, that's what I heard. So I'm going to write what? Nice. What do we do? Okay, are there any like terms to combine? No. So now what? Subtract 2x from both sides. And what do we get? 7. All right. The variable disappeared. 7 does not equal negative 3. So there is no solution here. Okay, the last problem, what should we do? Distribute first. What do we get? 12b minus 6 equals negative 6 plus 12b. All right, now what? Look for like terms to combine. Do we have any? No. So now what? Subtract 12b from both sides. And what do we get on the left? -6. What do we get on the right? -6. That is a true statement, so my answer is all real numbers. We do have to say real numbers because there is such a thing as an imaginary number. Imaginary numbers exist, even though they don't exist. You'll learn about that in Algebra 2. Yeah, don't even try thinking about it. Imaginary numbers are not real, but they exist. This is a little summary of what we've done so far in this entire chapter, sections 1, 2, 3, and 4. When you solve an equation, use reasoning to select the properties of equality that produce simpler, and I used this word earlier today, equivalent equations, until you find a solution. These steps are a guide on how to do that. Step 1, use the distributive property. That's what we're just doing, to remove any grouping symbols. Use properties of equality to get rid of your decimals and fractions. We did that the other day too. Remember when we multiplied the whole thing times something to get rid of that denominator? Combine like terms. Look, it's not even my rule. The book even put that down. Combine like terms always, anytime you do anything. Use the properties of equality to get the variable terms on one side. That's what we're doing today. And the constants on the other side. We're doing that today. Once you've done that, then you just solve, like section 1 and section 2. And then check your solution, of course, in the original equation. Go all the way back to the beginning, plug that thing in, make sure you got the answer right. Do that. Look in the back of the book. Make sure you have your answers right. There's no excuse. All right, that's it for the section. Have fun.